All right, so what I'd like to do next is sort of talk about what atomic mass actually means on the periodic table. So, if you remember, atoms are made up of different elements are made up of different isotopes of that element. So they have the same number of protons, but they'll have a different number of neutrons, and so their masses will be different. So mass isotopes have their particular masses. Okay, but when we say so, that's like um, I don't know, individuals in a room, right? If you wanted to know what their masses were, they would each have their own mass, right? But then if and so let's say we have boy elements and girl elements, for lack of more creativity at 4 in the morning or whatever it is right now. But let's say you have these elements and you have boy element and girl element, and you want to know the mass of one particular atom of that element. Well, you'd have to go weigh that one to know what it weighed, right? But then it turns out for atoms, right, the way the isotopes work, you might have 9 protons and 9 neutrons, and there'll be a whole bunch of those, and there might be some with 9 protons and 10 neutrons, and there'll be a whole bunch of those, right? But those isotopes would all have exactly the same mass. But if you wanted to know the mass of the whole group, right, then what would you have to do? You'd have to add all their weights together and divide by the number of boys in the group, and you do the same thing with the girls. You would say, well, if I wanted to know how much that atom weighed, that girl atom weighed, I would have to weigh each one of them in order to figure out what their masses were. But if I wanted to know the average, then I would take all their masses, right, add them together, and then divide by the number of atoms in that group. So this is the equivalent of mass of isotopes. These are of the individual atoms. And then the mass of the element is sort of the average mass. Now, in order to do this, though, right, if you wanted to do it right, not only do you have to know the mass of, to get the average, the mass of each of the individuals, you have to know how many of each mass you had. So let's say you had a bunch of um 11-pound boys. I don't know, just made that up. And a bunch of 12-pound boys and a bunch of 13-pound boys, right? Then what you'd have to do is you have to say, well, how many of these 13-pound boys did I have? And you take 13 pounds times that number, right? This is known as the abundance. But we usually do it as a percentage. And then in addition to the abundance, we have to know the mass of each one of those. And then what we would do, we would take the abundance, we would multiply it by the mass. And this would give me the total mass. But just of the one isotope, so this is the 13 pounders, right? Maybe I should have said fish. One of my boys was 10 pounds. How's that? On birth. That's what anyways, long stretch of a story, but that's what I always thought of in my head. And then there'd be some 12 pounders, and then you'd need the abundance of those. And then you multiply by their mass, which would be the 12, right? This one would be the 13, and then it would be the abundance, and then you get a total mass. Now, if you want the average, then what you do is you add those total masses together, and then you take the total abundance and you divide by that. Okay? So let me show you how this works for atoms. So we're going to use percent to do the calculation. So what does percent mean? This means per 100. Okay? And lithium comes in 2 masses. Okay? It comes in this atomic mass of that isotope. Lithium-6 has an atomic mass of 6.015, which is close to what we'd expect because its mass number is 6. It should be close to 6. Lithium also has lithium-7, right? Lithium, the element, is also made up of lithium-7, And so that one has a mass of very close to 7. It's 7.016. But the percentages of them are very different. Okay. There's only 7.59% that have that mass of 6, but the 92% of them have the mass of 7. So you know, like the average for all of them is going to be much closer to the 7 than to the 6, just because there's so many more of lithium 7s. So what did I say we do in order to figure out the average mass? You take the mass times the abundance. The percent is a representation of the abundance. 7 times its percent abundance, and then we're going to get numbers for those. Okay, so let me pull out my super sophisticated calculator, and I'm going to go 6 point, oh, I can do it with my pen, 0.15 times, right, 7.59. And that comes out to 45.65 385. Well, let's just do 45 point. Well, I better do it all. So I'll do this. I'll copy it. Maybe it'll work. And then I'll paste it. Oh, it's a much bigger thing than I wanted. All right. I'll just type it in. 45.65385. 45.65385, like that. And then we're going to do the same calculation for lithium 7. We're going to take its mass, 7.016 times 92.41, and I'm going to get 684.34856. And gosh, I don't think I'll remember that number, but we'll do it in 2 bits. 648.34856. Like that. And then I'm going to add those two together, right? So to add those together, I'm going to go 45.6535885 plus that number. So I'm going to do it in reverse. I'm going to say plus, there we go. Let's see, what is it? 45.65385, like that. And hit equals. That comes out 694.00241. Okay, like that. Now, here's the thing. That's for 100, because it's percent. So I'm going to divide that by 100, and I'll get 6.940, which then should have sig figs to the 6 here, so it should have sig, so 6.94. And this is in atomic mass units. I forgot to say that these are measured in AMU, but I think that was kind of understood. All right, and now let's go look at the periodic table. So we're just going to go back up to here, the one I stole. And let's look at lithium, and what do we find? It's 6.94. So that's actually how all these numbers that are on our periodic table, all of these are derived. We take, for each element, the stable isotopes that we can get, right? We just grab a bunch of that element from nature, and we count the number of each type of isotope we have, and we measure its exact mass, and then we average them together using this technique of multiplying and then dividing by 100, okay? So this is what I'd like to do, right? Oh, and actually, just to go back, notice it says 6.94, and we said it would be closer to this one than to this one. So it is, because there's 92% of it that's the atomic mass of 7. All right, so that actually answers this question that's down here. All right, so I want you to try it with this set of numbers. This is for magnesium, right? And then we'll check to see how close we are on our periodic table. But the way you're going to do it, right, is think about it. I know the abundance of each, that's my percent. I'll multiply by the masses of each, right? And I'll add all that together and then divide by 100. So that's the method you'll use for all of these problems to calculate the mass that we find on the periodic table. So I'm going to pause it, I'm going to fill in the numbers, and then we'll chat about the result. Okay, so there's the result. I just took these numbers and multiplied them out. And I got these numbers on the right, and I kept track of the significant figures on this one. They're each to 4 significant figures because the percents are measured to 4. But that puts the last significant figure in different places. So the last significant figure is this 0 because of the 4 up here. I add all those up, I get 2,430 point, then a bunch of numbers, right? But that's again the mass of 100 because we said percent, which reflects if you had 100. So then I divide by 100 and get 24.30 for the average atomic mass of magnesium. And then when I go back over here and I see magnesium 24.30, right? 5. So it's actually 24.31, but with as far as significant figures go, those numbers are essentially the same because they are only different in the last significant figure. So that summarizes this chapter. If you take these notes, I'll give you the whole notes. You can go actually to the end, and then I have some other notes that I've typed in here that maybe you want to take a look at. But I used to give an additional lecture in lab, and those are the notes from the lectures that I used to give in lab. Again, like always, if you have any questions, feel free to send me a message and ask me your questions or put it on the discussion board and then send me a text and I'll answer it. My headphones died. And my headphones died. And then I'll answer it um, on the discussion board so everybody can sort of benefit from your question. All right.